Hey there, Pre-Calc cats. All right, we have a rational function. We want to analyze it, so let's get right to it. This will be a nice review of everything. Actually, this is a nice review of almost everything we've done up to this point all year. So, what should my first step be according to this chart? All right, let's factor it. It's a difference of squares. Who would have thought it? So my bottom factors into what? X minus 3, x plus 3. Anyone disagree with the 3? All right. Do you all want a review on how to factor when you have an A? I'm going to slide and divide. Do you have to do it that way? No, but I'll give you guys a quick reminder because I don't think it hurts anyone to do it. Although this is lagging really bad, so it might hurt me. So I'm going to slide that 3 to the back. And that becomes what? -9. Is that a factorable problem?
Yeah.
Yeah, x minus 9. Oh man, maybe if I walk over here it'll be better. So I do x minus 9. I usually don't stand over here, it's weird. X plus 1, right? Does anyone disagree on that? Thank you. Divide by 3. So I'm going to divide that by 3. I'm going to divide this by 3, right? Aye. Does 9 evenly go into 3? Yeah, so I get x. I'm just going to write up here if that's okay with you guys. So I get x minus 3. Oh my gosh. And then the other side, what do I do if it doesn't evenly divide? Remember, you don't have to slide and divide. But in all my years of teaching different methods, slide and divide is by far the quickest way to do these without guessing and checking. All right. So we oh man, I was supposed to do that in that box. No, whatever. Which cancel? So my simplest form of this is 3x plus 1 over x plus 3. Now think about this. Do you guys remember on the video I did? All right. Do you guys remember on the video? Leading coefficients, if they're the same power, give us horizontal asymptote. Is 3 my horizontal asymptote? Okay. I'll go over it. All right, let's scroll down. Let's scroll down. Let's scroll down. All right, so do I have a hole in this graph? If you look at the picture, we can see the hole, right? It's at 3. Now, that's according to the graph. Does that fit in with our factoring? What canceled? The x minus 3, right? So if x minus 3 cancels, that means what happens at 3? A hole. Now we want the coordinates. What's my y coordinate? What can I plug that 3 into my original equation to get it? No, because it'll be 0 over 0. Can I plug 3 into this and get it? What's 3 times 3 plus 1? 10 over, which is what? Oh, lag city, man. Yep. Or you could also call it 1.6 repeating. Okay. Now, based on this graph, just by looking at it, what's my domain? Is there anything restricting me plugging anything over here to my equation? When's my first restriction? At the asymptote at 3. Does that make sense based on this? because I can't plug -3 into the bottom, right? After -3, am I good to go? Until +3. Does that make sense? Yes. Remember, your domain is anything the bottom can't be. So we set the bottom not equal to 0, and that will tell us what x cannot be. Jiminy crickets. Domain, remember, the bottom, oh my gosh, the denominator can't equal 0. So when does it equal 0? At -3. Can I include that -3? Heck no. That's an asymptote. And oh my gosh. This is the worst it's ever lagged. -3 to 3. And from what? 3 to infinity and beyond. There we go. Now for the range, what am I looking at my x or my y? So what can't y be? Y can't be 3 and it can't be 5/3. So I have to jump over those points for my range. Yeah. Oh man. All right, so can I go to -infinity? Can I go to 5/3? Can I touch 5/3? Nope, so I'm gonna do what with it? I'm gonna jump over it. Like Mario, boing. That's the best Mario noise I got, guys. Oh man, when we got time, I got strong opinions about the Mario movie. I finally watched it. It's super, as the kids would say, mid. So where's my asymptote at? Was it at 3? Wait a second. Is that graph on? Oh no, they're both at 3. At 3. And then from where to where? All right. So one thing I don't like about how this box is organized, I will always find my asymptotes first, and then I usually go through and answer these. Because I know the asymptotes are where there's jumps, right? Where I can't touch. Yes, but what if we weren't given the line? Because this next homework set, you don't get the graph. You have to come up. Nope, non-calculator. So remember, for your vertical asymptote, that's when the bottom equals 0, right? You're doing the same thing for domain and vertical asymptote. When the bottom equals 0 is a vertical asymptote, unless it's a hole, right? So when does my bottom of the factor and simplify equal 0? At x equals 3, right? -3. You're just looking at this one. When does the bottom equal 0? At -3. Now, how do I find the horizontal asymptote? There's 3 cases, right? Are my powers the same or different? If they're the same, we use the leading coefficients, right? So it's going to be y equals 3/1. Honestly, you guys are going to get to the point where horizontal asymptote is the nice question. You look at it and you're like, I can just look at the thing and get the answer. No math required, really. Yeah. All right, let's figure out these limits then. Let's take it to the limit. How am I going to do this and get the graph on the same page? You guys want to see some math magic? Where's my mouse at? I can't handle this. All right, so what we're going to do is, this is why they pay me money. Watch this. You guys said I couldn't do it, and I can do it. I heard you, Nate, saying I can't do this. I mean, oh no.
Edit that out.
Nathaniel Hackett is what I was talking about. The coordinator. No, the coordinator for the... Whatever. It doesn't matter anymore. I won't be here tomorrow. It's kind of funny. All right. He's a coordinator, right, for some team, right? Oh, yeah. I would fire anyone with both those names. All right. So here we go. What's my limit as x goes to negative infinity? So now what? This is my where. As I go, am I going left or right? Left. Because this is where negative infinity lies, right? Negative infinity. I can call it infinity because we go way back. You guys got to call it infinity. We've known each other forever. All right. So as I go to the left, what's my y value going to get close to? 3. What should if you have a horizontal asymptote, your limit as you go to negative infinity is going to approach your horizontal asymptote, right? So let's change color. Let's use this purpley blue, this blue blurple. What happens is I go to positive infinity. So I'm hanging out over here with positive infinity. I'm still approaching 3, right? I'm still approaching 3. Do I ever touch 3? Not in this one. I don't know if it shows up in this class, but you can cross an asymptote and come back to it. Yeah. I don't know. Now it's even more or less confusing. All right. What does this read as? X approaches. Dude, that was on point. You're approaching negative 3, and the minus means from the left, right? So as we approach negative 3 from the left side, what does it go up to? It goes up to infinity. Right? So what does this one read as? X approaches negative 3 from the right, the positive. What's up?
Can't you just tell, like, if there's 2 negatives, that makes it positive?
No, these are different. This is direction. This is the function. The negative at the end has nothing to do with the actual number. It's just telling you which direction you're coming from. Because do you see when we come from the left, it's positive, but when we come from the right, it's negative. Oopsie. All right. Now, what about 3? 3 is right there, right? Yep. Now, what happens? Why am I using limits at a hole? Can I reach the hole? No. But we want to know what happens when I get really close to it. So I can approximate a value. So what happens as I approach 3 from the negative side? What am I getting really close to for my y? 5/3. What about from the other direction? Is it 5/3 from both directions? Oh, do you know what that means? If the limit exists from both directions, that means a derivative exists from both directions. That's a calculus thing. This actually, when I taught calculus, the first unit is this. This is actually the same as the first chapter in calculus, what we're doing right now. Yes. Why are you surprised?
Yeah.
Chimney crickets. If I wanted to be made fun of, I would go home. All right, I'm going to cheat. That's true. All right. Do you all agree? Do you want to take the time and actually go through and plug this all in our calculator and take that? Or do you just... All right, so I'm going to give you the chart. Because that tornado that just passed by really got in our way. So copy down the chart. This would be a question they're going to give you where they give you the chart of values and then they ask you to give like asymptotes and stuff based on the chart of values instead of like the function itself. And I'm going to show you how to break down the charts. Okay. So yes, we are given the function this time, but when we go through this, I'm going to pretend like they didn't give that to us. Okay. They gave us the function, but I want to pretend like they didn't because I want to see if we can figure this out without knowing that. I hope so. So it's my first day here. So which one?
The one left of 0. They're not supposed to be a decimal there.
No, it's supposed to be really big. It's supposed to be really big.
What makes that?
I'll show you. We'll figure it out. We'll think about it. Before we get started, what are some things we notice about these numbers?
Really big or very small?
Really big or really small? Where's my undefined ones at? So what do we know is going to be happening at those points if they're undefined? Either a whole or a asymptote. It has to be one or the other, right? Pretend like we don't know this. So now, at this undefined, what happens right to the left of it, just a little bit to the left of it? It's really small, so what's it going towards? Negative infinity. What's happening just to the left of it? It's going to positive infinity. That's why those numbers are so big. Does that make sense? Because it shoots up. Now what's happening to the left side of 4? They're the same. So at 4, would this be an asymptote? It'd be a whole. What do you think the value is of the y at that whole? So do you see how we can use a chart to see what's going on too? Now, as we get really small, what happens? 0.998. What's that getting really close to? 1. What's it getting really close to as I get really big? So what would that mean? 1's a horizontal asymptote. So do you see how we can kind of use this chart to also see what's going on? You know what I mean? It's the same as having a graph, right? This is a hidden graph. As we get really small and big, we approach 1 from both sides, right? That's an asymptote. We have our holes or asymptotes. If we get really big and little, it's an asymptote. If it stays the same, it's a hole. Holy moly. Let's see if that matches with what we said. Do we agree with that? We're approaching 1 from both sides. If you ever forget and you cannot factor an equation and you get stuck on one and you know there's an asymptote but you can't see it, plug in like a 1,000 into the function. If you plug in a really big number and then plug in a negative really big number, you'll get an idea of what's happening at the end behavior. But you guys do have graphing calculators, so you can also use that. So, yeah. But it is actually easier to use your power rules because these have the same power, right? X squared over x squared is 1. All right, anything scary there or okay? So now B, we talked about as well. We know -2 is a vertical asymptote because you guys notice, you thought there should be a decimal point there, right? Just to the left of -2, it got super small. It went to negative infinity, right? On the left side of it. On the right side, it got really big. So we know it's going to shoot off into space or shoot down into Hades. Am I allowed to say that? Okay.
It's on video. What's going on in that left corner of my anatomy?
They got, never mind. All right. Now, as you approach -4, it was the same on both sides, right? You could put 1.167 was what it was, right? You could put that on both too, but I just rounded 1.2, or they did. So we would assume that there's a hole in the graph and the coordinates are 4, 1 point whatever, or you could use the fraction. Both are acceptable, okay? Now, I would have probably just done 4, 1.167. You could also, if you're given the equations, I want to pretend like we weren't given the equations though. You could plug it into the simplified form, right, to get your y coordinate. Not the original, because that'll give you 0, 0. Why are holes important to know? So you don't fall into them. No, because there might be functions that can be simplified, but you need to know the values that don't work, because then you discard them. Okay? So that would be like 4 is one that we'd have to discard. If you take, you'll learn more if you take calculus. Which I don't know if I'm scaring y'all off from it. This is pretty much calculus, actually. This is actually more steps than real calculus. Anyway, well, for basic problems. All right. What do you know about g of 0? Oh. It's 1.5, because what did the chart tell us? At 0, it's 1.5. What's that? That's our y-intercept, right? You plug in 0 to get your y-intercept. That was a big question I got asked on the homework, is how do I find the y-intercept? You plug in 0 for x, and that'll tell you where you cross the y-axis. Okay. Or if you get a baloney holding call, then it won't intercept. Hashtag NFL loves Kansas City. I'm sorry. Not to get political. Alright. Now how do you find zeros? Oh, I should have done this. Zeros, you set the top equals 0. Set the top equals 0. Now why do we disregard the 4? Because that one cancels. That's a hole, right? That's a hole. So we set the top equal to 0, and we get our zeros at -3, 0. Okay? Set the top equal to 0 to find zeros. The bottom to find your vertical asymptotes. And then you plug in 0 for your y-intercepts. I'll say it again. Set the top equal to 0 to find your zeros. Set the bottom equal to 0 to find your vertical asymptotes. You plug in 0 to find your y-intercept. I think on your homework there's like blocks that had to find all 3 things. If you know your asymptotes, you know your domain, right? Okay. And what's the last one? Ooh. Based on the table, can I find where g of x is greater than 0?
Yeah.
So what I would do, sometimes my brain don't work good, okay? So we know 0 at negative, why you know work as well? Why speak many words when few words do trick? I don't know, because we're verbal animals. All right. Based on this chart, where's my asymptote at? -2, right? Someone put an asymptote at -2. What happens on the left side? And then what's my horizontal asymptote?
-2.
At 1, right? Wasn't that 1? Yeah. What's happening on the left side of -2? Right? Where does it cross right here? What point is that? -3, right? Because that's my 0. Do you see how I told you eventually we'll be able to sketch these graphs without a calculator, right? This is what we're doing. You draw your asymptotes, you put in your zeros. My other 0 is at 1.5, but that doesn't really matter. What happens as I approach -2 from the right side, according to the chart? So that's a good sketch. That's a sketch of my graph, right? So where is this function bigger? Oh. And what happens at 4? So where is this function greater than 0? -infinity to -3, right? Then where? Yep, I gotta go from left to right when I read it, right? When we do it. Am I just to the right of -2? Am I positive? So, but not at -2. At -2, I'm nothing. I'm a Mr. Twilliger. That was really harsh, actually, to myself. From -2, what happens at 4, though? So you're nothing, right? Never mind. You're how many touchdowns did the Cincinnati Bengals score last week? And then from 4 to infinity. You have to leave out the 4 because is that 4 even part of our function? Does it even go here? No. The 4 is not part of the domain. It's like me sitting by myself at lunch in middle school. Jeez Louise, I gotta stop. Why not? All right. Let's see if it matches with what I just said. Yep. The number one mistake made on these is people forget about the hole, right? Because if you graph this in your calculator, will it show you the hole? No. It will not show holes. Does this match with what we had up there? Okay. So then we're also less than 0 from -3 to -2. So don't forget to leave out the holes. What's a donut without a hole? Actually pretty good, like a fritter or a tiger tail. Yeah, that's valid. Jiminy Crickets. Are we going to make it?
Also, when you look back at the video, when you like shit, definitely not
We're going to do this one more. We'll finish this tomorrow. I'm going to do this relatively quick, though. Actually, Jiminy Crickets. Your slant asymptote?
Yeah.
Which questions are with that? That's fine. You know what I want you guys to do? I want you to work with a partner and do example 7 and see how you do. And then we'll go over it. I want you guys to try it, though.